Hello, welcome back to my channel, and I'm your Nimisha. So, this will be a complete NLP tutorial. Whether you are a beginner or you are just brushing up your skills, this video covers the NLP theory and hands on practical labs. Okay, from scratch. Let's get started. Before that, if you are new to this channel, please don't forget to subscribe my channel and also enable the notification bell. This will be an NLP bootcamp from zero to hero in NLP. Let's start our session. So, first of all, what is NLP? What is exactly NLP means? It's a subset of artificial intelligence. Here you can see NLP is a subset of or subfield of artificial intelligence. It helps the computer to understand or to interpret or to generate the human language. Here we can see the simple definition. NLP is a subfield of AI and linguistics that focus on interaction between computers and human language. Okay, the main goal of NLP is to, I already said that, to understand, to interpret, to generate, and to respond to the human language in a meaningful way. This is the best definition for NLP. You can use this definition for your interview perspective. Okay, and coming to the key functions in NLP, let's go to the some real world example first. Okay, for example, Chat GPT. It's a great example for our NLP, right? Or Google Translator, or even what email spam classification. Okay, or auto suggestion. These are the greatest examples for NLP. And here I listed few key functions in NLP such as text and speech understanding, text generation, translation, sentiment analysis, named entity recognition, speech recognition, question answering. We will discuss all those things in the next few hours. Okay, so one second. And these are the few techniques that we are going to cover in the entire series. Not in series, in this video, this will be a single video in which we are cover from basic to advanced level. Okay, so we will cover tokenization, lemmatization, stemming, POS tagging, tag of words, TF-IDF, word to vec, advanced word to vec. Okay, and also okay, we can cover the deep learning models in a separate video, deep learning video. Okay, in this we will cover till this. Let me add few more topics also. Wait. So our agenda. Let me type our agenda first. We will cover both theory and practical in this series. Okay. So first thing we will cover the text introduction. We just introduced about the course and all. That's not important. First thing we will cover the text pre-processing. Okay. And in this we will cover tokenization, stop word removal, then stemming, lemmatization. Okay. Then we will cover text vectorization, such as bag of words, TF-IDF, then n-grams. In n-grams, we will cover unigram, bigram, trigram, and also skipgram. Okay. Then in the next session, we will cover word embedding, and here we will cover word to vec and average word to vec, and also we will implement Gensim. Okay. So we will cover all those things in theoretical plus practical way. Fine. So let's start our class. We already discussed what is NLP. What is NLP? NLP is nothing but it's a subset of artificial intelligence which helps the computer to understand, to interpret, and to generate human language. Or it's simply it focuses on the interaction between computers and human language. Okay, fine. And these are some examples in real life, such as Chatbot, our ChatGPT, or voice assistant Google Assistant Siri, Alexa, or email spam filtering, or autocorrection, or customer segment analysis. There are a lot of examples in the real world itself. Okay, just try to figure out the examples, and maybe in next video we can try few examples as a project. Okay, for example, ChatGPT clone, not clone, other app chatbots apps, or email spam filtering. We can do it as a project in upcoming videos. Okay, fine. So coming to our first topic, text pre-processing. What do you mean by pre-processing? It's nothing but cleans and standardize the text for analysis. We got a raw data, right? Raw data consists of lots of impurities such as null value or some duplicate value. So we have to do pre-processing before we are analyzing or before we are building a model. So here in the NLP perspective, the text pre-processing is cleaning and standardizing our text for analysis. So we are using a lot of method for that. And the first one is tokenization. So what do you mean by tokenization? Tokenization is nothing but simply breaking down our sentence or paragraph into small unit called tokens. For example, this is my sentence. I love NLP. I love machine learning. Okay, so we split those things into, maybe if we are using, there are different types of tokenization. Okay, let me say that also before that. Okay, and second, we have to say a few more things before this concept. There are a few terminologies. Okay, corpus. Corpus is nothing but a paragraph. Okay, and here we can say documents. Documents is nothing but our sentences. Then we have vocabulary. Vocabulary is nothing but unique words. Here, what is a vocabulary? This is our corpus. Okay, this is our corpus. So, what is the vocabulary here? What's the vocabulary? I love NLP, then machine learning. So vocabulary is nothing but unique word. We are removing the duplicate words. Okay. So in this vocabulary we have vocabulary size. What is the vocabulary size? 1, 2, 3, 4, 5. Here vocabulary size is 5. What is the word count? Total word count? 7. Right. So we removed I and love, duplicate words. So our vocabulary size is the count of unique words. Got it? Yes. So in tokenization, coming to the tokenization perspective, one second. Okay, coming to the tokenization side, it is nothing but we are splitting or we are breaking down the sentence or paragraph into small unit called tokens. And these tokens can be word, sentence, subword, character, depends upon the type of tokenization that we are using. Okay, there are different types of tokenization. For example, if our sentence is I love you. Okay, and if we use word tokenization, the sentence will split into words. For example, I love you. Okay, then if my sentence is hello NLP is good, if this is my sentence, and if I implement sentence tokenization, the word will be, one second, the token will be sentence and it's split like this. Hello NLP is good. It will be split into sentence. Okay, if you are using word tokenization, the token will be word. So the paragraph or the corpus or the sentence will be split into words. If you are using sentence tokenization, the paragraph will split into sentence. So the token will be sentence. Okay. Or if the word is unethical. Okay, if this is a word and we are using subword tokenization, the token will be subword and it will split into un and ethical. Okay. Or if you are, if my sentence is hello and we are using character tokenization, this will be HELL, sorry, O. Okay. So the token concept, the in tokenization concept, the paragraph or sentence is split into the small unit called tokens, and those tokens can be different depends upon the tokens that we are used. It can be word, sentence, subword, character. Okay, it depends upon the token that we are using. I hope you got the concept. Okay, so we can implement a few practicals on the concept of tokenization right now. Let's get into the practical side. Tokenization. Okay. So we can, first of all, we have to install a library called NLTK. For that, pip install NLTK. Just wait for a few seconds, okay? Yes, requirement already satisfied. I already installed it. Maybe a few of you already worked with the machine learning concept or already did some few projects. So you already, its requirement already is satisfied. Okay, NLTK already installed in my system. So if you are not installed, if you didn't install NLTK, you have to use this command to install. Okay, fine. So first tokenization, we can convert a paragraph into small sentences. Okay, or we can convert into word. Okay, there are a lot of there are different types of tokenization are available. So first we can convert a paragraph into sentence. For that we have to use send tokenize function. Okay, so from n nltk dot tokenize import send underscore tokenize. Okay, then okay, let me add a corpus first. Corpus equals hello, NLP is amazing. Welcome to my channel. Okay, this is my corpus and I'm implementing sentence tokenization. Okay, so first of all, we imported the libraries. Then we have to use 1 second s1 equals send tokenize. We have to pass the corpus. In Google Colab you will get auto suggestion, so I prefer to use Jupyter Notebook in order to understand, in order to practice more. Okay, if you're experienced one you can use Google Colab, no issues for the auto suggestion. But if you're a beginner, don't use Google Colab, it will suggest the next code, so most probably you won't get any error. Okay, so use Jupyter Notebook. Then we can print s1. It will give us a list. Okay, which there is an error. Let's check the error. You will also get the same error. What's the error? You have to import NLTK and download this. Okay, so here you have to type this code, import NLTK and download the Punky tab. So here what happened? The paragraph is split into sentence. Okay, here is our first sentence, here is our second sentence. Okay, similarly we can convert this into words, that we have to use word tokenization. and in that we have to import from NLTK. See here we got the auto suggestion from NLTK.tokenize, import word tokenize, and we created an object by passing the corpus, and we can print it. So here what happened? The paragraph split it into words. Okay, the comma, the dot is also considered as a word. I hope you got the concept. Okay, let me add a semicolon here. Semicolon, not semicolon, full stop. Okay, see, dot is also considered as a word here. Fine. Okay, there is another type of tokenization, that is word punct tokenization. Let me add that also from NLTK dot tokenize, import word punct tokenize. Okay, it's similar to word tokenizer, but here, wait. Let me change the corpus. Okay, let me give few changes in the corpus. Hello, NLP is amazing. Welcome to my channel. I am Nimisha Davis. Okay, let me run this. Okay, this is two sentence. Here we got it as a three sentence. With okay, one, two, three sentence. And here what happened? See, I am. I am is a single word, but it treated as a separate word. The punctuation is treated as a separate word. Okay, so here what happened? 1 second. Here punctuation and M both treated as a separate word, but here in word punct tokenization, punctuation is separately treated as a word. Okay, it's not linked with a word. Here in word punct tokenization, it treat punctuation as a separate word. Okay, I hope you got the concept. Then there is another type of tokenization, that is tree bank word tokenizer. Okay, so let me add that also. From there are a lot of tokenization, you can use whatever you want in your project. Okay, tree bank word tokenizer. Okay, here what happened? Here we do not treat dot as a separate word. Here in word tokenize, or here in word punct tokenize, the decimal or the dot, it treats as a separate word, right? But here it doesn't treat as a separate word. Wait, let me show another thing also. Here let me add a full stop. Word tokenizer, word punct tokenizer. Here. What's the difference? In word tokenize, the decimal point or the comma, not comma, the decimal point is treated as a separate word. But in tree bank word tokenizer, the decimal point will not treat as a separate word except the last decimal point. See, except the last decimal point, the decimal point will not treat it as a separate word. Decimal point or full stop. Okay. I hope you got the concept of tokenization. What is tokenization? Tokenization is nothing but splitting the paragraph or sentence, or breaking down the sentence into small unit called tokens. Okay, fine. Coming to the next one, what's the next topic? Stemming. What is stemming? Stemming is nothing but it's a simply a process of reducing a word into its word stem that affixes to suffix and prefixes to the root of the word, which is known as lemma. Okay, word stem is nothing but simply remove the prefix or suffix. Okay, So there are lots of different types of stemmer class similar to the tokenization. We have a different type of tokenization, right? Similarly, there are different types of stemming. First one is regex stemmer. In this, it helps us to uh, implement regular expression easily. Okay, it helps us to implement the regular expression stemmer algorithms. Regex means regular expression stemmer. Okay, it basically takes a single regular expression and removes any prefix or suffix that matches the expression. Okay, for example, if our word is running, okay, if my word is running, it will convert it as run, or if my word is gone, it will convert it as go. Okay, so the suffix and prefix will be removed, or simply it reduce the word into its word stem. Okay, so there are different type of stemmer, regex stemmer, porter stemmer. So you can implement those things. Okay, let me do the practical section one. Wait. Okay, yes. Stemming. First one is porter stemmer. Yeah, you already got the stem suggestion. So we have to import it from nltk.stem import porter stemmer, and we have to create an object for the porter stemmer function. We created object ps. Then we have to use the use the function that is stemming. Okay, so let me run this. So running will convert it into run. Okay, let me check the gone. Gone is same as gone. Let me check going is converted into go. Okay, so let me do one thing. Let me add a corpus first. Okay, corpus equals mm, running going history class. Okay, this is my corpus, and here we are passing our corpus. Before that, we have to use a for loop for to iterate everything. So for I in corpus print I plus, let me represent it by like this, plus ps dot stem, and in this we can pass our I. Okay, so what happened? It treat each and every characters. Okay, let me do one thing. Let me give it as a list. Fine. Okay, this is running, going history class. This is our list. So what happened? Running have, okay. Running is converted into run. Going is converted into go. History is converted into history. Class is converted into class. It's not 100% perfect, right? Is it correct? No, right? So Porter stemmer has some disadvantage. Okay, the entire meaning got changed. This is a major disadvantages of the Porter stemmer. Okay, we can also use regex stemmer also. Wait, regex stemmer. So for that, from nltk dot stem import regex p stemmer, then rs equals regex p stemmer function, then Let me run this. Okay. What's showing? It's missing an argument. Positional argument is missing here. Maybe that's corpus. We can pass corpus here. What's another next error? What's next error? Unhashable type list. So if you are using a regex stemmer, we have to pass a pattern. Regex means regular expression, right? So we have to pass the pattern here. Okay. So let me remove this rs equal. Here is a pattern. I mean, if the word ends in ing or e, that's a pattern. Okay. So running ing will be removed here. Okay. ing. But running runn. There is also few mistake in this, right? So protostemmer, regextemmer. In regextemmer, we have to pass the pattern in order to get the output. But both of them have few disadvantage, few mistake, right? It's not 100% perfect. Or if you are passing, let me add another word here also. Wait. Congratulations. Congratule. Is that even a word? Here we got congratulation correctly. Okay, because we passed only this pattern. If we want to pass another pattern, let me add s. So it remove the last s. Here also we got the class. Here we got a club. Here the word s all got removed. Okay, so we can add another thing here. Dollar symbol. Dollar symbol means last words. Okay, if we don't use dollar symbol, it will remove the word character from the word itself. It will remove if you don't use dollar symbol, see, it removed the s from the third position, right? So if you want to remove the characters from the last position, you have to give the dollar symbol. Even though if we give the pattern, there are few mistakes in the regex stemma, right? Supporter stemma, regex stemma both have their own disadvantages. Similarly, we have another type of stemma, that is snowball stemma. From nltk.stem import snowball stemma. Okay. SS snowball stemmer equal to, here we have to pass the language, in which language it is written. Okay, we have to pass the language. It is better than the Porter stemmer. Let me convert it. Run, go, class. History is same, right? And congratulate is also the same. So there are few disadvantages in the stemming process. Let me add another word here also. Wait. Fairly. It's converted into fairly. And what about regex stemmer? Okay, we have to remove this. Okay, wait. ly dollar. So here we can get it in a fair, right? Here what happened? Similarly, here we can get as a fair, output as a fair, right? So snowball stemmer is little bit better than the porter stemmer. But all of the stemming have few disadvantages. What's the disadvantage? Some words will entirely changed. The meaning of some words will got entirely changed, right? Congratulation is converted into congratule. Is that even a word? No, right? So to reduce or to help or to solve the problem which is caused by the stemming, they introduced another concept that is called lemmatization. Okay, lemmatization. It will solve the stemming problem because it have the dictionary of all root words. Lemmatization have the dictionary of all root words. So it will gives a good grammatical form. It's similar to stemming, but it have all the root words in its dictionary. Okay, and the output that we will get after the lemmatization is called lemma. Okay, which is a root word rather than the root stem. In stemming, we will get a root stem, right? And in lemmatization, we will get a root word that is lemma. Okay, root word in lemmatization. In stemming, we will get output as a root stem. In lemmatization, we will get output as a lemma. Okay, or a root word. I hope you got the difference between them. Okay. So after lemmatization, we will be getting a valid word that means the same thing. For example, if we add sung or if we add sings, it will give sing or sung. Okay, it will give the proper meaning. It will give the proper word. Fine. Okay. So in lemmatization, let me give the code of lemmatization. Also, wait. Lemmatization. In lemmatization, there is a class called wordnet lemmatizer class. Okay, which is a thin wrapper around the wordnet corpus. And this class uses a morphe function to the wordnet corpus reader to find a lemma. Right? So let me implement a small lemmatization concept using wordnet lemmatizer. Okay. So from yes, here auto suggestion from nltk.stem import wordnet lemmatizer and let me remove this. Let me create a object le equal wordnet lemmatizer, then le dot lemmatize function. Here we can pass going. Okay, what's the error? Okay, we have to import, sorry, download this. Okay, okay, going is same as going, gone, gone, then okay, we are using going, right? In lemmatization, there is another concept called POS. What is POS? Have you heard the word POS anywhere? POS tagging. Did I write it here? Wait. Here you can see parts of speech tagging, identifying the grammatical role of a word. Okay, here in the lemmatization, we can pass the POS tag. That means what in what type or in which form that we have to convert the word, whether it is a verb or noun or adjective or an adverb, what we want to convert into. So we can pass POS equals, if you type N, it will convert it into, oh sorry, it will convert it into noun format. If we type V means verb, again verb format, then adjective, it will convert into adjective. If we give R, it will give convert into adverb. It's there is no change here in the going. So let me add a corpus. Okay. So at net limitator for I in corpus, we already have a corpus, right? Print I le dot lematizer. Here we can pass I pos equals, we can pass the verb. Okay, there is some issue here, right? What's the issue? Okay, what happened here? We pass the verb and the running is converted into run, going is converted into go, history is converted into history, class into class, congratulation into congratulation, fairly into fairly, right? So similarly, if we pass the adjective, it was converted into its adjective form. Or if we pass adverb, it will convert into adverb form. Or noun, it's converted into noun form. Okay, most probably we are using verb. Fine. So here is the best thing, right? In rugged stemmer, porter stemmer, snowball stemmer, everything we got a mistake. We got an incorrect word. So while using lemmatization, we got a best perfect word which have a grammatical meaning. I hope we got the difference between them. Okay. So where we can use these things, we can use it in ChatGPT or Chatbot or text summarization processing or even a Q&A session. Okay, we can implement all of those things. We will do project later, okay? Not in this video. In the upcoming videos, we will do a project using this complete NLP. Okay, fine. One second. I'm getting a call. 1 minute. 1 minute. Okay. So that is lemmatization. And coming to the next topic, that is stop word removal. What do you mean by stop words? I'm sorry. What is stop word? Let me add another tab. Stop words example means I, the, to, of, etc. She, is. All these things are stop words. 1 second. Okay, I just got a call. So sorry for that. I don't know whether it's recording or not right now because when I post the recording, after then when I resume it again, the recording will got automatically stopped. I don't know what happening. So let's hope it's recording. Okay. So these are the stop words. We have to remove those words. The words which is doesn't have proper meaning. Okay, it have meaning, but it's for example, I ate food at ABC restaurant. It is great. Okay, so the main important word is ABC restaurant, food, and great. These are the important words, right? So we can remove is, I, at those words. Okay, so those meaningless words are known as stop words, so we have to remove those words. So for that we can use stop words. Let me import it. Okay, first of all we have to download those stop words. Wait. Okay, from nltk.corpus import stop words. Okay, we already downloaded the stop word, right? So don't need to download it. So stop words equals set of stop words dot words There are different types of stop words. I mean, from different language, from English, Malayalam, there are different language. So we can pass English here. Okay. Then filtered equals W for W in tokens if W dot lower, not in stop words. Then print filter. So before that, we have to add some tokens here. Tokens equal to word tokenizer. Then we can add what's our corpus? Corpus. Okay. Word tokenizer. Word tokenize. Which okay, we got a except string bytes. We got an object. Okay, fine. Which. W1. Okay, we replace this sentence into list in some word. Yeah, here we replaced it into list. That's the issue. Okay. So here what happened? We don't need to print it here. That's a word organization. Okay, let me print that also. Okay. So this is after word tokenization and this is after removing the stop words. You can see the difference, right? I, is, to, my, it's all got removed, right? So in stop word, we are removing the meaningless or useless, not useless, meaningless words. Okay, not important words. Fine. I hope you got the concept. I hope you got the difference between stop words and also normal word tokenizer. Okay, fine. So we can also implement the Alma beta. Yeah, okay. So we can also implement the stop words with the lemmatization. So we will get more accurate answers. So I implemented with word tokenizer plus stop words. So you can also use lemmatization plus stop words or stemming plus stop words. Okay, just try that. Fine. So 1 second. Okay, fine. So what's the next topic? POS tagging, right? So here in lemmatization, we checked some POS tag, right? Where is that? Yes, here we added some POS tag, right? 1 second. Okay. So here in lemmatization, we are reducing a word to its base or to its dictionary form, which is called a lemma. Okay, using the POS tag and morphological analysis. Fine. But the here we added a word parts of speech tagging. parts of speech tagging and here POS tag. Both are different but have same impact, or it is related to each other but have distinct task. Okay. The POS tagging or parts of speech tagging and the lemmatization POS tag are related but have distinct tasks. In POS tagging, let me add that. Wait. POS tagging. Okay. In POS tagging, it is a process of labeling each other word in a sentence with its appropriate parts of speech such as noun, verb, adjective based on its definition and context. For example, it's the same as in the lemma but have distinct way of approach only. Both are same. Yeah, noun, verb, adverb, adjective, those are our POS tag. Okay, those are our parts of speech tag. Fine. Okay, so let me give you a practical example. Both are similar but have distinct way of approach. So we have a corpus already, right? Yes. So okay, we can implement this thing. From nltk.tokenize, import word tokenize, then we convert it into word, right? And here, from nltk import post tag, there is a tag called POS tag itself. We passed in a parameter or an argument in a lemmatization that's similar to this. Here we have a function called POS tag. Okay. So wait, one more thing. There's an error. Yeah, we have to download this. So what's happening here? In parts of speech tagging or POS tagging, both are similar. In lemmatization, we implemented the POS tag. Similarly, we have a function called POS tag. Okay, POS tag function in which we can get each word post tag. I mean, hello is NNP or comma is just a simply comma. NLP is also NNP. Ease is WBZ, amazing is JJ. Okay, we can get what is that exactly meaning. For example, mm, wait. Let me give another sentence. She is running fast. Okay. This is a simple sentence which is converted into post tag. Here we can see what are the post tag mean, what's the explanation for that. So here she is PRP. PRP means personal pronoun. Okay. And is WBZ. It's a verb. Sorry. That means verb base form. Okay. VBZ. Then running is VBG, that is verb past tense. Sorry, not past tense, present participle or verb. Okay, and RB means maybe 1 second. RB means I forgot that. Yeah, it's an adverb. Okay, RB is an adverb and VB is a verb. VBG is a verb participle. PRP is a personal pronoun. And DT, if you see DT, that is a determinator. Running too fast. Two is a two. Okay. Two means two as in go. Those all words are comments to this. Okay. Two means to go. First to school. Okay. School is a noun. See. So in parts of speech tagging, we are getting the parts of speech or what's the each word means actually. Okay. I hope you got the concept. POS tagging, in POS tagging, we will label the each word in a sentence according to its parts of speech, such as noun, verb, adverb, past, present, something like that. Okay, so we implemented these things were in lemmatization concept, right? POS. We passed it as an argument. Here we used it as a post tag function to get each word appropriate POS. Fine. Okay. Then the next thing we have to learn about, wait. Okay. Next thing we have to learn is name entity recognition. So we have to import this thing. Before that we have to download it. Okay, wait, download max ent chunker. Okay, then we can pass our corpus. Let me remove the unnecessary things. Okay, we can pass the corpus. Then yeah, we can use this thing. Yes. Okay, so from NLTK import word tokenize, W1 word tokenize. Okay, we tokenized in using the word token. We don't need the post tag. Okay, so here, yeah, no issues. Post tag we can add is, let me save it as a P1. Okay, then nltk dot ne underscore chunk. Here we can pass our post tag dot draw. Okay, let me run this. Okay, we got an error. So let me download another thing, nltk dot download words. What's the next error? Oh, we have to download this thing. What's the next one? No display name, so no display environment variable. nltk dot ne chunk p1 dot draw. One second. Okay, let me cut this. Then here we can add nltk from nltk import post tag. Okay, maybe it's not working in the Google Colab. Just try this code on your Jupyter notebook. Fine. For Google Colab, let me write another code. Hmm. Okay, let me create something like a tree. Okay, C1 equals NE underscore chunk. Here we can pass the P1, then 4 subtree in C1 if is instance, then subtree comma tree. Okay, then print the above. The third line will work on your Jupyter notebook. Okay, my system is too slow, that's why not using the Jupyter notebook right now. So you can use your Jupyter notebook, no issues with that. Okay, we have to import a tree here. These are not necessary if you are getting the third line. Okay, what's here? Any chunk is not defined. Yeah, we have to define that also. From NLTK dot no, from NLTK import any chunk. Hello is GP NLP's organization, Nimisha Davis a person. But this is not the thing I am going to show you in this command. It will draw the code. It will draw like a tree structure. Let me show named entity recognition. See, not like this. It's just like it show like a tree format. Okay, when you run that code on your Jupyter notebook, it will show like a tree code. Tree. Yes, like this one. So try to run the third line on your Jupyter notebook. Okay. This may be due to some Google Colab issue. Google Colab have some limitations, so just try it on your Jupyter notebook. If you got the answer, just comment down below. Okay. Fine. So we learned about stemming, stop word removal, tokenization, lemmatization, right? I hope you got all concept clear. Let's go to the next topic, that is text vectorization. What you mean by that? To use this text in machine learning model, we need to convert those words into numbers, which is known as vectors. We have to convert those text into vector format. If you already learned the machine learning, you must heard the topic one hot encoding or label encoding, right? What's happening though? In that, we will convert the text into numerical form, zeros and ones, right? Similarly, the text vectorization is the process of converting words into corresponding vectors in numerical forms. Okay, so I'm not going to take one hot encoding here. I hope you guys already covered in the machine learning concept. So in one hot encoding, the main disadvantage is it's have a sparse matrix, right? I mean, it have zeros and one. For example, um, the food is good. The food is bad. If these two are our sentence, and if we implement one hot encoding here, what's our vocabulary first? Just write our vocabulary. What's the vocabulary? The food is good, bad. This is our vocabulary. Okay, vocabulary size is 5. So, if we implement the one hot encoding, one second, press 1. The is present, right? So, we write 1. Food is also present, again 1. Is also present, 1. Good present, 1. Bad present, no. In S2 sentence, the is here, yes, yes, no, yes. This will be the output that we get after the one hot encoding. Here we can see zeros, right? If the word is not present here, we simply add 0. That is a sparse matrix. Okay, one hot encoding is very easy to implement using Python, sklearn, or one hot encoder, or you can use Pandas get dummy function. Okay, but the main disadvantages is sparse matrix. Everything is ones and zeros. Okay, if you implement the machine learning algorithm in this, maybe it will lead to overfitting also. Okay, fine. So another thing is that if we plot this thing, okay, if we plot this line in a 2D two-dimensional space, for example S1 and S2, only these two difference are here, right? So if this is S1 and S2 will be somewhere near to this, so both words are near to each other. Maybe it will think as both are similar words, both are similar lines. But in the real scenario, both are entirely different, right? But when we plot this into a 2D graph, it will stay too near each other and it will think as if both are similar, both are same because the distance between them are very, very minute. So that's the main disadvantages of one hot encoding, that is it have a sparse matrix. Okay, fine. And so you just try to implement one hot encoding from the machine learning perspective. I already covered those things in the machine learning classes, but it's in Malayalam. I hope you guys already know machine learning concept. So here we are using another um, method that is called bag of words. Bag of words. So let me give an example. Hmm, food is good. Food is bad. No, no, not food. Apple is good. Pizza is bad. Apple and pizza is good. This is our sentence. Okay. And this is our text. And we got the output such as okay. Here we got the output for 1 here. Okay, pizza is good. Okay, let me add this thing. Pizza is good. Also here we got output as 1 hash 1, and here also we got output as 1. Okay, so in bag of word concept, first we have to convert all of the text into lowercase and we have to apply the stop words. Okay, convert to lowercase, then we have to apply stop words here. Okay, after applying stop words, what will be our vocabulary? Good, apple, pizza. This will be our vocabulary. What's the frequency of vocabulary? How many times good is repeating? 3. What about apple? 1. No, 2. What about pizza? Again 2. Okay. So, if we implement these things into the bag of word concept, let me add those things. Wait. Okay. So, if we add in this bag of words concept, our features are good, apple, pizza. And we have two sentences, S1 and S2. In S1, good is present, so we add 1. Apple is also present. No. Apple is present, we add 1. Again, here 0. And in S2, good is present, apple is not present, then pizza is present. And in S3, good present, here yes, here yes. This will be the output that we got after the bag of word implementation. Okay, I hope you got the concept. Okay, in one hot encoding, we wrote vector for each and every word. But in bag of words, we will first convert into lowercase, then we apply stop words, and we will implement the bag of words in the vocabulary only. Okay, not for the entire word. We implement it only in the vocabulary. Got it. This is binary bag of words. This is binary bag of words. There is another concept called normal bag of words in which we have features good, apple, pizza, S1, S2, S3. And here, what's the count of good? Good, 1, 2. Okay, for example, let me add another thing also. Apple is good. Wait. Good apple is good. This is our sentence, first sentence. For example, just consider it. Okay. So in normal bag of words, we will take the count of the words repeating, count of the vocabulary repeating in the sentence. Here it will turns into 2. Apple is 1, pizza is 0. Okay. Balance all are same, right? 1, 0, 1. 1, 1, 1. So here in normal bag of words, the pictorial representation will be little bit easy compared to the last one, right? Here, if it is S1 here, S2 will be here and S3 will be here. There is few distance here. In binary bag of words, most of them are similar, just nearby each other. Okay. So what's the difference between one hot encoding and binary bag of words? In one hot encoding, we will convert each and every word into vectors. But in bag of words concept, we will apply bag of words in only in vocabulary. We will apply stop words here. Okay. And coming to the normal bag of words, we will take the count of each and every vocabulary that is repeating in each sentence. Okay. I hope you got the concept. I hope you got the difference here. Okay. And here also we are getting sparse metrics, right? Zeros and ones, which is also leads to overfitting. Okay. And And here in simple vocabulary, sorry, in simple bag of words, the another disadvantage is based on the vocabulary frequency, the order of the sentence got changed. Similarly, the meaning will be also changed. Okay. So the main advantages is that it's simple and the input size is fixed so that it will help to train the machine learning algorithm efficiently. Okay, so I hope you got the difference between one hot encoding, binary bag of words, normal bag of words. Okay, so let me implement those things here. Bag of words from, I'm sorry, from sklearn dot feature extraction dot text import count vectorizer. Okay, then we can pass our corpus. No, we can pass the list. Okay, NLP is fun. I love NLP. This is our corpus. Fine. Then we can create the object for count vectorizer. Then yes, we can print this. Okay. Here what's happening? NLP is fun and NLP is great. Let me do this. This is normal bag of words. Okay. Here getting we are getting the count and this is the coordinates. If we represent it into a two-dimensional, this will be the coordinates. Okay. So if you want the vocabulary, what vocabulary is using here, if you want to know that, cv dot get features name. Wait. What's here? Count vectorizer has no object names, not names. Names out. These are the vocabulary that we are using. And fun, great, is love, NLP. Okay. So here, what's happening? We are removing the stop words. We are implementing this thing only in the vocabulary. Okay. I hope you got the concept. If you want to implement binary bag of words, here just pass a parameter binary equals true. So it will shows the binary. Yes or no values only, zeros and ones only. Okay. If we didn't pass the binary, it's simply normal bag of words. It will get the count. Here also we are getting a sparse matrix. So it maybe leads to, it have a chance for overfitting. Okay, fine. So coming to the next thing, next one is TF-IDF. TF-IDF. What's meant by that? Term, frequency, inverse, document, frequency. So what do you mean by TF-IDF? There are some equation for TF-IDF also. Simply, TF-IDF is used to transform our text into numerical features. Similar to this all are comes under the text vectorization. Okay. So here it will tell how important a word is in a document relative to a collection of documents. TF-IDF will tell us how important a word is in a document relative to a collection of document or corpus. Okay. So for example, okay, S1. Let me write it here. TF-IDF. S1. This is our sentence, that is good boy. S2. Good girl. S3. Boy, girl, good. If this is our sentence, and the equation for term frequency, TF. Equation for TF and equation for IDF both are different. So equation for TF is number of representation of word in a sentence divided by number of words in a sentence. Number of representation of words in a sentence divided by number of words in not representation, repetition. Okay, repetition, representation both are same. In a sentence. Okay, this is TF. So what is IDF? IDF is log to the base E into number of sentence divided by number of sentence containing the word. Don't look at the spelling. I'm just simply typing as fast as soon as possible. Okay. So what's the equation for TF-IDF? That is TF into IDF. Okay, these are the equations that you have to remember well. So let us implement those things into our approach. Okay. So our vocabulary is good, girl, boy. This is our vocabulary, right? And we have three sentences, S1, S2, S3, and we have to find the IDF. IDF also. Okay. So first we have to find the TF for this, then we have to find the IDF. So TF for the word good in the S1 sentence. What's the TF? What's even by TF? Term frequency. What's the equation? Number of repeating word. Number of repeating word. Repeating of not. Number of repeating words in a sentence divided by number of repeating name, number of representation. Okay. For example, good is our vocabulary, right? In first sentence, how many goods are there? Only one, right? Okay. So here we write 1 divided by number of words in a sentence. How many words are there? 2. 1 by 2. 1 by 2 is the TF for the word good in the sentence S1. So what about in the S2? Same, 1 by 2. What about in the S3? 1 by 3. Okay. We can calculate IDF later. First we have to calculate TF. So the girl in the sentence S1, 0, right? There is no word girl. 0 by 2, 0. And S2, 1 by 2. And in S3, 1 by 3. Okay. Coming to the word boy. In S1 sentence, 1 by 2. In S2 sentence, 0. In S3 sentence, 1 by 3. These all are the TF value of the vocabulary. Now we have to find the IDF value. Okay, what's the IDF value? Log to the base E into number of sentences. How many sentences we have? 3. 3 divided by number of sentences containing the word. How many sentences the word good contains? 3 sentences. So 3 by 3. Log to the base 3 by 3 equals gives 0. And here log to the base E into total number of sentences 3 by Number of sentence that containing the word girl. How many sentence? Two. Okay. Similarly, to the boy is log to the base e 3 by 2. So this is the TF value and this is the IDF value. Now we have to calculate a TF-IDF. Okay, 1 second. Okay, now we have to calculate TF-IDF. Simply we can multiply those values. Okay, let me S1, S2, S3, then good, boy, girl. Okay, so for S1, we have to multiply TF into IDF value. Okay, what is S1? This. So 1 by 2 into IDF value is 0. So here 1 by 2 into 0, that is 0. And coming to the boy, in S1, boy 1 by 2 into log to the base 3 by 2. Okay, 1 by 2 into log to the base into 3 by 2. Just do the equation, just do the calculation. Okay, I don't want to waste time for the calculation. Similarly here 0 into log to the base e into 3 by 2. Okay, so just do the other thing also. Here, if you want to get the TF-IDF, just multiply the corresponding value of TF into the IDF. Okay, so after getting the values, here we will get a values, right? Getting the value, we will train the model. So here also we are getting sparse matrix. Here still this parsing exists. Here parsing still exists. Zero still exists, right? But what's the difference between bag of word and TF-IDF? In bag of words, each word got equal importance. Okay, let me show that. In bag of words, each word have 1, 0, 2, something like that. But here, each word will get a value, right? Okay. In TF-IDF, each word have its own importance. I hope you got the concept. But still, the sparsing is exist here. So let me implement the code. 1 second. I'm getting a lot of calls today, so okay. In TF-IDF, let's implement those from sklearn dot feature extraction dot text import TF IDF vectorizer. Okay, you have to import this. Then TF IDF equals TF IDF vectorizer function. Then we can pass our corpus here. Then we can print it. Then we can get the answer. Okay. So these are the value. If you want to convert this value into array format, just type x dot to array. Okay. So you have to add a bracket more. So it will convert into vector format. Sorry, array format. Okay. These are our value. These are representation. Still here we can see the zeros. Sparsing is still exist. Okay. I hope you got the concept of difference between one hot encoding, bag of words, normal bag of words, binary bag of words, and TF-IDF. Fine. Okay. Then we can add another concept that is called wait. engrams. So what do you mean by engram? There are different types of engrams are available, such as unigram, bigram, trigram. Okay, so engram is nothing but it's just a sequence of n number of words or tokens from a given text. Okay, so we use the engram in some tasks like language modeling or text generation or sentiment analysis and so on. Okay, so in bag of words or in TF-IDF, we are using vocabulary or each word, right? Single word. That is unique gram concept. Means single word, one gram or a unique gram. But in n gram, we can use unigram, bigram, or trigram. For example, if this is our sentence, I love you, baby, and love you NLP. If this is my corpus, if I implement unigram concept, each word will be split into one words, right? I mean, I love you. We can split like that. Okay, in unigram. In bigram, we will split into two words. For example, I love you, baby, and love you NLP. Okay. In trigram, similarly, we will convert into three words. I love you, baby, and love you NLP. Okay, so here, why are we using engrams? To capture the word context. Okay, it will help to understand sequence and the structure of the word. Fine. So we can let me show another example also. Wait. Yeah, this is our sentence, right? If we apply bigram, we will check I love is present here or not. Yes, one. You baby is present. Yes. And love is present. Yes. Okay. If we have another sentence, I love cricket. This if this is our sentence. Okay. Cricket is not present in the first sentence. So in the second sentence, I love is present. You baby is not present. And love is not present. UNLP is not present. Cricket is present. Right? If we implement trigram, similarly, it will check I love you is present in the first sentence, you baby and love is present, UNLP is present, cricket is not present. And here in the second sentence, I love is present but not I love you. So 0, 0, 0, here 1. Okay, I hope you got the concept. What is bigram, what is trigram? Okay, so let me implement a simple code of n-gram concept here from nltk dot util import ngrams from. Okay, then we can by equals list of ngrams. Here we can pass our tokens. Okay, and if you give 2, that means bigram. Okay, wait, tokens is not defined. Wait, where is the token? Okay, let me use this word tokenizer. Okay, not token, we can pass w1. We can remove this. Okay, So it will convert it into two. See, hello and comma and NLP and is. See, if you are using three, it's trigram. Okay, I hope you got the concept of this. Okay, this is using simple Python NLTK library, or we can also implement using sklearn. Let me show that also. From sklearn dot feature extraction dot text import count vectorizer. We can pass our corpus like I love NLP. NLP is fun. Okay. Vectorizer. We can create an object for count vectorizer. Here we can pass n-gram range 1 comma 2 1 comma 2. That means it will consider unigram plus bigram. Okay, 1 comma 2 means unigram plus bigram. What's here? See, fun is fun, love NLP is. Here we're getting single word and double word, right? If we are giving 1 comma 3, that is unigram plus trigram. Okay, if we are giving 2 comma 3, that is bigram plus trigram. Fine. I hope you got the concept or the difference between unigram, bigram, and trigram. Okay, fine. So we learned about text preprocessing and text vectorization techniques, right? And coming to the next part, our third part, that is word embedding. Word embedding. What you mean by word embedding? In bag of words and also in TF-IDF, we are simply ignoring the word meaning. But the word embedding will fix this by placing similar words closer in the space. Okay, so we can use, there are two types of word embedding technique, that is word to vec and also the average word to vec concept. Okay, and second, okay, wait. In word embedding, it is divided into two. First one, count or frequency based word embedding. Okay, such as one hot encoding, bag of words, TF-IDF. We already discussed about it. And the next thing is deep learning based, deep learning trained model based. Okay, that is word to vec. Okay, word to vec and average word to vec. In word to vec, it's again divided into two, that is CBOW and skipgraph. Okay, so these are the things that we have to learn. Okay, so wait. So what is word embedding? So word embedding is nothing but simply the representation of words for text analysis, typically in the form of real valued vector that encodes the meaning of the word, such as the word that are closer in the vector space. Simply nothing but converting the text into vector format. Here we will get a symbol meaning that will allow us to placing the similar word closer in the space. Okay, so we can use the technique called word to vec first. Okay, so word to vec is a technique for NLP, which is published by Google in 2013, I think so. And it's an algorithm which uses the neural network model to learn the word uh, from a large corpus of a set. Okay, so once trained, such a model can detect the synchronized words or similar word or suggest additional words for a particular sentence. Okay, so as the names imply, it represents each distinctive word with a particular list of numbers called vectors. Word to vector format. Okay, so in bag of words in TF-IDF one hot encoding, we have a major disadvantage that is called sparsing, right? But in here, in word embedding, sorry, in word to vec, there is no concept for called sparsing because, for example, good, bad, boy. If this is our vocabulary, each word will get a value. Good, that means 1. Bad means extremely negative, opposite of good, right? So we can give -1. Boy, good, bad, boy. Boy, maybe it's not related to good or bad, right? So we can give 0.2. Okay, so in word to vec, each and every word will get a value. Even though it is a negative, even though it is a decimal, even though it is a positive value, each word will get a value. Each word will convert to vector format based on the vocabulary feature representation relation. Okay, so the Google word to vec have 300 dimension vectors. You can just check the Google word to vec Google. See? Word to vec is a specific word embedding technique that uses a neural network model to learn word association from a reasonably large corpus of text. After training, the model can detect similar words, recommended words to complete the partial sentence. Okay. As its name suggests, the word to vec map each distinct word to a vector which is assigned in a such a way that the level of semantic similarity between words is indicated by a simple mathematical operation on the vectors that the word are mapped. For instance, the cosine similarity between the vector. Okay, here you can see the dataset include pre-trained vectors trained on a portion of the Google News dataset which consists of hundreds billion words. This model contains 300 dimensional vectors for about 3 million words and phrases. Okay, this library can be loaded using Gensim. This dataset can be loaded using Gensim library. Okay, so we can use it in our coding. Import Gensim from gensim.models import word to week. Okay, so we can give our sentence equals NLP is fun. Okay, I love NLP. Fine. Then we can give model equals word to vec. Here we can pass a sentence. Then vector size equal to 100. No, we can give 50. Then we have to pass the window. Window equal to 2. Then min underscore count equals 1. SG equals 0. Here SG equals 0 means we are using SIBO method. We already said that word to vec have two divisions, SIBO and skip gram, continuous bag of words and skip gram. So if we are giving ST equal to 0, that means we are implementing SIBO here. If we are giving ST equal to 1, that means we are implementing skip gram here. Okay. Then we can print model.wv of NLP. New module called Gensim. So we have to download this. Wait. I got an error. Wait. Okay, we can use the Gensim in Word to Vec and Doc to Vec. There are so many things are available. Oh, sorry. So we can just import Gensim. We got an error. Okay. Just we can use pip install Gensim. Okay. It will take some time. Okay, Gensim is installed. There is a few error in that. But what's the error? Okay, fine. Before that, let me show you something more. Okay. So let me show about SIBO. Okay. SIBO means continuous back of words. It's fully connected neural network. Okay. So here we have an input value and also we have some output value, right? So for example, this is my corpus. Google is a best company. Okay, this is my corpus. And in word to vec, we have to add a window size. Okay, here let me add the window size to 3. Okay, so window size 3 means we are choosing first 3 word. Okay, as our first input. Okay, first 3 word as our, not first 3 word, we are taking first 3 word and the middle word will be our output and balance word will be our input. Okay, window size 3, so we take first 3 word. Google A is our input and our output will be is. And again we are shifting the window size from this to this, is a best. So A will be our output, is and best will be our input. Okay, again we are changing the window to the next 3 one, A best company. So A and company will be our input, best will be our output. Okay, this is really happening in the cbow and skip graph. Okay, so we are setting a window size. It's like it indicates how many data that you need to select. Okay, we are selecting first 3, In the next step, we are selecting the next three. Okay. So the middle value will be our output. Here we are getting 3 input value and 3 output value. Okay. So I'm going to train this. I'm going to train my model using this input and output, but it's a text value, right? So we have to convert this text into vector format. So maybe we can apply one hot encoding here, or any type of text vectorization you can apply here. Google is a best company. This is my sentence. We can apply one hot encoding. Okay. So, one second. Google is a best company. So, here Google is present, right? So, 1. Is not present. 0, 0, 0, 0. I mean, this is the vector format of the word Google. 1, 0, 0, 0, 0 is the vector format of the word Google. And here 0, 1, 0, 0, 0. This is for is. Okay. And for A, 0, 0, 1, 0, 0. And for best, again 0, 0, 1, 0. And for company, 0, 0, 0, 0, and 1. Okay, these are the vector format, vector representation of each word in the sentence, right? Okay, so I already told you that it's fully connected neural network, right? So if you already know the deep learning concept, maybe you can understand this well. Otherwise, just keep this in your mind. Okay. So if you represent the neural network, first we have input layer in SIBO concept, right? Okay. In SIBO concept, we have input layer, then we have hidden layer. I mean our window size. Then we have our output layer. So we have how many input? 1, 2, 3. We have 3 input, right? So 1. Okay. 3 input in which each word converted into 1, 2, 3, 4, 5. 5 vectors, right? So let me add that also. 1, 2, 3, 4, 5. Okay. So we have 3 words. Okay, this is our input layer. Input layer. Okay. Then we have our middle layer, which is our window size. What's our window size? 3. Okay. Let me give 1, 2, 3. This is our hidden layer or window size. Window size, what's our window size? 3. Okay. Then we have our output layer. What's the output value? Is a best. Okay. Output layer also contain how many values? 6 vectors. Not 6, sorry. 5 vectors. 1, 2, 3, 4, 5. Okay. If we connect these things, we will connect, wait, each and every dot. See, we will connect each and every dot. Wait, let me connect this. Okay, we have to connect this. And also to next thing. Okay, we have to connect each dot also to the next one. Okay, and here also we have to connect 3 dot into each line. This will be the SIBO connection. Okay, we have to connect to each other. Fine. So all these lines have initialized weights which happens in ANN concept. Maybe if you already know the deep learning concept, you can understand this easily. Simply each layer connected to each other. Okay. So after training, we got a value, and using we can implement the loss function also here. Okay, so if we increase the window size, it's better for our model. Okay, so what is skipgram? Skipgram is entirely opposite to this. Here our input value is this, right, and output is this. But in skipgram, this will be our input value and this will be our output value. Okay, in skipgram, this will be our input and this will be our output. And the entire picture, this entire picture will got reversed. Okay, this will be our input layer and this will be our output layer. Okay, so when should we apply the SIBO or skipgram concept? If we have a large data set, we can implement SIBO. We can implement skipgram. If we have huge data set, we can implement skipgram. Huge data set, skipgram. If we have small data set, SIBO. Okay. So how we can improve the SIBO or skipgram? We can increase the training data. We can increase the window size. Okay. There are a lot of methods to improve the SIBO or skipgram. Okay. So we are using word to vec Gensim concept. Maybe we already tried this. Wait, let me try again. Okay. We have to use exclamation pip install Gensim. Requirement already satisfied. Okay, let me run this again. What's the error? Okay, import Gensim. From Gensim model start import word to vec, then create vectors. Okay, then import gensim dot downloader as API. Then we can implement mv API dot load. Okay, we can add this. Then vec king equals wv of king. Vec underscore king. Huh? Okay, except 96 from the C header, got 88 from the pi object. NumPy d type size changed. Import Gensim. Pip install is successed, right? Yeah, requirement already satisfied. We already run this. Maybe the version of NumPy and Gensim is not match. So let me do one thing. Pip install upgrade NumPy Gensim. Okay, which okay, let me upgrade this and try again. Okay. Okay, that's not happening. Let me wait. I installed it right now, right? So let me restart the session and run now. Yes. Wait for a few seconds. Okay, it's downloading. It will take some time because it's a 1662 MP. Okay, because I already told you that Google Word to Vec have 300 dimension vectors or 3 billion words. So we have to download everything. Otherwise, we can use another thing, normal Word to Vec function. First, let me show this thing. Okay, I can also give you the normal Word to Vec function example. So, model equals Word to Vec. Here we can pass the send. Then the vector size equals 50. Then we can pass the window equals 2, min count equals 1. Then if we want to pass CBO, we can give SG equal to 0. If we give SG equal to 1, that means skip gram. If we give SG equal to 0, that is CBO. Okay, when we can print model.wv of NLP. Let's wait. You have to download this first. So let me do one thing. Let me post the video because it will take some time. Okay. I don't know will it record or not. Let's wait. Okay, it got downloaded, but there is some error here. Okay, that is not WV, it's MV. Here we have to give the send. Just wait for a few seconds, okay? Just wait for few seconds, okay? Or you can just forward the video. Yeah. So here we can see we implemented an API of Google Word2Vec 300, which consists of 300 dimensional vectors. So we convert the word king into a vector format. This is the vector format of the word king. This entire thing. See, and here, let me run this. Uh, wait. Send NLP. KWV. See, here is the vector format of the word NLP. This is normal word to vec, but this one is Google word to vec. It consists of 300 dimensional words. That is why it's very huge. Okay, I hope you got the difference. Okay, so we can either use normal word to vec function, or we can use the Google word to vec. Okay, fine. So this vector represents the word NLP with embedding the similar words like close in the multi-dimensional space. Okay. So another thing is that average word to vec. Average word to vec is nothing but we are taking the average of the vector. For example, this is our SIBO, right? If we have, wait, let me draw first. Okay. 1, 2, 3, 4, 5, 6, etc. to 300 time. Okay, 300 dimension. Right? If you use Google bag of words, it have 300 dimension, right? Just consider this is a 300 dimensional vector. And if we have 6 words in that sentence, so each word will represent as a 300 dimension vectors, right? So total 300 into 6 dimensional vectors. So in the average word to vec, what is happening right here means we are taking the average. For example, we took these things and we are taking the average of this and put it into a single vector. Okay. And again, we are taking another line. Then we take an average at here. Okay. So overall, we are taking we are converting the entire sentence into single 300 dimension vectors. In average word to vec, we are taking the average of all dimensions we already created in the word. Simply, we are we are converting the entire sentence into single dimensional vector, single 300 dimensional vectors. Okay. Otherwise, in normal word to vec, if we have 6 words, each word will convert into 300 dimensional vectors. It will be huge data, right? So we are taking the average of it. I hope you got the concept. Okay. So we can implement it using a function. Just we can create a function def avg word to vec. You can give any name. So here we am passing the send and also the model. Then vectors equals model dot wv. Here we can pass word for word in yes. If len of vector equal to 0, otherwise we can give this if word in model dot wv, then we can give this. We don't need this. We can give return np dot mean vectors. Okay. Let me check. Okay, okay, okay. For word in sent, okay, we can directly give this. Fine. Then we can pass the sent. Okay, this is our sentence, and we are passing the sent and model to it. Okay, we can do one thing. Send is average, not average, AVG WV of NLP. Now we can just pass like this. Okay. So what's happening here? We created a function. Okay, to get the average. So let me run this here. Just see, we are getting a single vector. See, we are getting single vector. Okay, but here if we are using Google Word to Vec, we are getting vector for each and every words. Okay, I hope you got the concept, right? So till now we have learned about, let me go to the top, tokenization. And there are different types of tokenization. What is sentence tokenization, word tokenization, word punct tokenize, and tree bank word tokenize. There are lots of tokenizer. You can just Google it and find it out. Okay. And we learned the next text pre-processing step, that is stemming. And stemming also, there are different types of stemming: water stemmer, regex stemmer, snowball stemmer, right? Then coming to the third one, that is lemmatization. We are implemented wordnet lemmatizer, which is better than the stemmer. And also we learned how to remove the stop words using stop word function. And wait. Yes, we learned about the POS tagging. Okay, we already implement the POS tag in the lematizer, and also we learned the function called POS tag. Then we learned about named entity recognition, and just try to run this line in your Jupyter notebook. You will get the output like this. Okay. In Google Colab, most probably you won't get the output like that. You will get like this. Okay. Then we learned about the TF-IDF. Sorry, where is bag of woods? Yeah, here we learned about the bag of words, and also we learned about the TF-IDF concept, and then we learned about n-grams, bigram, trigram. We also learned a binary bag of words, normal bag of words. Okay, then we implemented Gensim, and we used Google Word to Vec API to implement the Word to Vec concept. Okay. Also, we studied about the average Word to Vec. I hope you got the concept. I know you will get confused at the first time, but you just have to try this code. Okay, you have to try yourself first. Just listen to me and do the code with me, and after that do the code by yourself, not looking or not looking by the Google. Okay, just do yourself only. So after that you can understand it A to Z or complete thing. Okay, so you have just learned the full NLP pipeline from cleaning text to turning into a powerful vector representation, right? So if you found this video is helpful, just hit like, subscribe, and just follow me on Instagram for more information, more tips, something like the AI, data science, or data analyst field. Okay, so that's all for this tutorial. and I hope you guys enjoyed it. And in the upcoming videos, maybe I'll try to cover the machine learning or deep learning concept in English as well. Because in my channel, most of the videos, not most, 99% of the videos are in Malayalam only. So I hope there are few students from the outside of Kerala, right? From outside of Kerala, maybe you can't able to understand Malayalam. So that's why I'm take a class in English in this video. If the video got most reach, at least 100 views, I will do machine learning, Power BI, Python, all videos in English as well. Okay. Yes. If you have any suggestion, you can just comment down below. Actually, I didn't prepare a note. That's the main issue. I don't have time to prepare that. From next video onwards, I'll try to prepare notes for you. Okay, so that I don't have to write it here. In this, I'm writing everything here, right? So if I prepare a note, I don't have to write it in this blackboard or whiteboard. Okay. So yes, that's all for this video. Thank you. Have a nice day. Bye bye. I don't know whether the video is recording or not because I posted twice. Let's see. Bye.